Okay. Now the next one, we're going to look at two general approach or two method we use to analyze the fluid mechanics problem. So the first one is Eulerian. The second one is Langerian. Okay, so there are two major approach, two method that usually we use to analyze fluid mechanics problems. The first one is called Eulerian. The second one is called Langerian. So Eulerian, the first method, is focused on space and time. Space and time, which is we covered what mean by space with this x, y, and z, the space. Time is a t, location. So Eulerian method will look into the function of space and time. And Langerian only look at function of time. So we'll look into more detailed explanation about these two. Okay. So I'll give you some time to fill in the blanks in the tutorial. So Eulerian and Langerian method.
Yeah.
Okay, done. Okay. Okay. Now, if you look at the diagram in your tutorial sheet, so you have on the left and on the right. Okay. So this L shape is actually a cross section of the cylindrical chimney, or you can imagine this one as a cylinder pipe, long pipe from a factory, and then there's a smoke coming out from below. Right, the red one is you represent the smoke. All right, so we have two method here. So I'll explain the first one. So imagine you want to study the smoke flow from below to bottom to the top. So if you're using Eulerian method, the first method, what mean by Eulerian method is that you use a probe sensor, or you stand stationary at this point, and then you measure what happened to the smoke. So the smoke will pass by. So a lot of different particles will pass by this point, and you collect whatever velocity that you collect from here. So this is the first method, referring to the Eulerian method. So for the first method, you will focus on the space, the x, y, and z position, space, and then the t, the time of collection. All right. So this is the first method. Now, second method is more simpler, where it will focus on the individual smoke particles, and then it follow the particles, rather than there's a fixed sensor compared to the first method. Okay, so Langerian method is focused on the individual particle and focus on time only. Means you follow the individual particles. While Langerian, it will just stay there and then measure whatever come into its way. Okay, so these are the two big difference. Of course, the more detailed explanation in you can read from the slide. So
It means the Eulerian method is like a fixed locations like that.
yes, it's like you tag a GPS chip on individual particles. Then you just follow. Then the Eulerian one is just a stationary signal sensor. Then you just stay there and measure whatever come into the direction. So it means it measure different particles for the first method.
Okay.
Okay. All right. Now, application of these two. Okay. So, for example, you have a buoyant signal that to measure the high and tide of the wave. So, if this sensor was tied to the bottom of the sea, the seabed, then this one become Eulerian method. If this buoyant sensor was tied to a stationary position, and it will just measure whatever wave they come into a direction, then it becomes first method. However, if you cut off the wire and you just let this sensor to flow along the wave, then it becomes the second method already. Okay, it become a Langerian method. So application of these two methods, one is on the weather forecasting and wave, our sea wave height, all this application of these two methods. Turtle journey. So this one is you can say as a Langerian method lah, because it take a GPS signal and then it will just follow this individual turtle to each one of the point. Okay. Right. Now we have clear question 8 about the two major method. So these two methods also sometimes very important for your simulation results or in your FYP if you deal with flow simulation. Right. Now number 9. All right. So we talk about number 9. Talk about three-dimensional flow. So just now the example we look at is on a two-dimensional. So we have to cover what happens if it's a three-dimensional flow. So you have a physical effect. So in this on the slide here, you see there's a vortices generated after the wing at the wingtip here at the back. So these are the three-dimensional flow effect. All right. So yeah. And this one is more on the wind tunnel test on the shape of the rocket. And then there's a smoke flow along the surfaces. So these are all the three-dimensional flow experiment. Right? And every time we mention about three-dimensional means we need to recall back the general form of our vector form. So vector, if we mention about three-dimensional, we have u I hat plus v hat plus wk hat. So this is a general vector form. If you look at the question and the question gives you a three-dimensional problem, then straight away you write a general vector form. Then you get a 3 marks for that. All right, now this is a three-dimensional. What happens if you only have two-dimensional flow? It means your equation only have a two-direction component. So in this case, this is an example of I and J. So it's also if you only have V equal to J hat plus let's say V and W K hat. This also two-dimensional, or it's in the other combination, for example, UI hat plus WK. So this also dimensional, two-dimensional. So as long as you only have two terms here, then it's a two-dimensional flow. Okay. Right. Now, one-dimensional flow means only you have one component. So this is only one component. So if your V equal to Vj hat, also one-dimensional flow. V equal to Wk hat, also one-dimensional. So in exam, don't confuse with if in exam if you like Uk hat, I'll give you wrong, or I'll put a question mark. What do you refer to UK hat? Because U always link up with I hat rather than K, because K always refer to Z direction.
You say the two-dimensional flow is it can be a Vj plus a WK.
Yeah, it can. As long as you're correct.
So it's like a, for example, XYZ, it means Y plus Z or X plus Z, like that.
Correct. So it means that in your equation you only have two component, two heading. Okay. So this is just a very straightforward example. So of course, if you go to work later on, you will see 3D problems and you simplify it into 2D problems. So you need to rearrange your equation into the reference coordinate now. So because sometimes when you go to work, you have a 3D problems, you have X, Y, and Z scenario, and maybe the customer only want to see this plane. What happened to this plane? So you just modify your equation to X and Z component. No? Then you have two-dimensional analysis, something like that. All right. Now the next one, we're going to look at visualization tools. With these three, we have streamline, stick line, and path line. So these three, the lines that I show you in the first slide just now, in the software simulation or the balls shape, all these are visualization tools for flow field. So I'm going to give you the application of these three types of lines. So if you want to do for mathematics analysis or just calculation, stick line and streamlines are often used for mathematics analysis or analytical work. However, the stick line and path line, these two, just now I mentioned stick line, so not this one. Streamline only for mathematics. So this one only for analytics. These two for experiment. Okay, so streamline means if you want to do your report and do analysis, then you focus on streamline. However, the data for stick line and path line you can only get from experiment. Okay? Or you can derive from streamline. Okay, it's very hard to get mathematics model straight from stick line and path line. So usually these two are from mathematics model or from experimental data. Okay. All right. Now we're going to define what is a streamline. So streamline, for example, if you draft out this diagram first, you have y and x axis, and then you have a curved line in the dark blue color. So this one is a streamline. So all the lines in simulation or in analysis actually is a combination of small little dot combine, and then you combine it, you integrate it, then you get a streamline. So the definition for streamline is a line that everywhere tangent to the velocity vector, means all the dot that I draw here actually is tangent to this curved line. Okay, all these are tangent, right? So this example will give you only selected maybe this point. Then you have one red color arrow from this point. Okay. Right. So this is a definition for streamline. It's a tangent to the velocity vector. All right. Streamline is a line where everywhere tangent to the velocity vector. Okay. So just a note for streamline. So if you have a steady flow, then you will see this kind of streamline. If you have non-steady, then you have this kind of shape. Okay.
The streamline is the red color line.
No, streamline is blue color.
Oh, okay.
Streamline is blue color. Okay. Yeah, streamline. Oh. Streamline is the blue color. So what I mean by this blue color? So blue color actually consists of many tiny points. All right, many small points. to consist of this line. So the definition of streamline is say that it's a line that everywhere tangent to the velocity vector. So if this point, it give you a tangent from this curve, tangent from this line, this dot, tangent from this dot, tangent from this dot, tangent from this, and you combine all these dots together, you get the solid blue streamline. Okay, this is the definition of the streamline. So means on a streamline itself actually is consists of many velocity vector, but the velocity vector is tangent to the direction of this blue color line. Okay. So steady flow and unsteady flow, you have to know from the shape of the streamline. So if in the diagram, if you see this kind of streamline, it means it's a steady flow. If you see something like that or something like that, means it's a unsteady flow. Yeah, we have clear streamline definition already. So you'll see many times on a streamline. You'll see many times on the streamline. Okay. Now the second one. Okay, before we go to the stick line and path line. So how do we generate streamline? There is a standard procedure already. So we look at individual point here. So the individual point by the definition of streamline. So we have all the vector is tangent to the path line. So tangent means you have you can draw the vector out, and then you have your dy dx. dy dx actually is the gradient of your red arrow, gradient of your vector. So again, you have y and x axis. So whatever go to the x, you denote as u. Whatever you go to the y, you have v. And this is the big V with a vector. Right now, how we generate streamline? We use integration method. So we're given you 2D dimensional problem. So we know that the slope of the streamline equal to tangent of the angle that the velocity vector reference to the x. All right, so this is the definition to develop the equation to solve or to visualize the streamline. So slope of the streamline equal to dy dx. This mathematical form. If you want to find the gradient equal to dy dx. However, if you put into the vector diagram, so you put the y direction vector divided by x direction vector, which is v divided by u here. So this is the first step when you want to solve a streamline problem. You always write this equation. Dy over dx equal to v divided by u. All right. Now another low-level understanding is that how you get dy over du dx. Oops. Is that you can use the definition of u divided by v divided by u. We know that velocity equal to distance divided by time. So v is the distance traveled in y divided by time. You get v. U is the distance divided by time in the x-axis. You simplify this equation, take out the dt, you still get back dy over dx. So this is a more simpler mathematical model to define dy dx equal to v divided by u by referring to this diagram. Okay, Then we look at one example on application of these slides. All right, this is question 15, question 15 in the tutorial question. So again, we use back this, sorry, question 12, not 15, question 12. Question 12. You use back the same equation just now. V equal to V0 divided by L negative xi plus yj hat. Again, in your handouts, in your tutorial handouts, there's a typo error in the x component. All right, make correction. It's not j hat, it's the I hat. All right. So where these two components, V0 and L, is a constant. Now we want to visualize the streamline. Want to visualize. So again, how to visualize? Again, all right. So let's break this equation just now. We know that u equal to this component, v equal to this component from the vector equation, right? Now u equal to negative v0 L times x. This is what we cover already. You should know from the velocity vector, the vector field just now. V equal to v0 L divided v0 divided by L times y. So this is a u direction, x direction, and this one is a y direction. So again, call back the streamline solution equation. You write dy over dx equal to v divided by u. So when you write this one, give you marks, this one give you marks, and then you write this equation, also give you marks, 1 mark. Substitution inside there, substitution sometimes no mark, sometimes have marks, because it's very straightforward procedure. So if you substitute the u and v value inside this definition for streamline, all right, you can take out the constant value. U0 divided by L is the constant value. Take out these two. You will get negative y divided by x. Okay. So this gives you 1 mark. Then after that, we will integrate this solution, this equation. Then we will get the streamline. Because our streamline actually is a linkage of many points on the streamline itself. So just now we arrive at this equation, dy over dx equal negative y over x. You want to integrate something, you need to rearrange the equation so that you can integrate. So y, you put y term in one side, x term in one side. So you move your y, this y to the left, dx to the right. Then you add in the symbol of the integration. Okay, symbol of integration. So recall back your integration knowledge. You integrate something 1 over y, you get ln y. You integrate something 1 over something, you get ln something. Of course, remember to carry the negative sign. And because we don't have boundary condition here and here, or here and here, we don't have. That's why we have a constant there. All right. Now, how you arrive from here, you need to refer back to your calculus integration chapter. Okay. All right. Now, you know that if you put ln y and then you pull this term to the left, you get ln y plus ln x. Ln y plus ln x, you rearrange, you get xy equal to constant. Again, this is a mathematic order. All right. So if you don't understand, you need to revisit your mathematics, revisit your calculus. All right. So far, yeah.
I
So far,
understood. So far good.
okay. Now, a procedure uh, for drawing out the streamline is actually simple. It's always start with dy dx. Okay. Always remember these steps. It's standard already. Always remember to write this one. Then substitute whatever for u and v, because in exam or in your real work scenario, the equation for your vector field will change. So you just need to find out for v and u, and this is a two-dimensional analysis. All right, we look at x and y component. All right, and then the next one, after you have a dy dx equal to v divided by u, substitute everything, simplify, then you'll get something x, something y. Right, this is normally it will not be the same, because the answer here will follow the given velocity vector. All right, so this is just a mathematic flow, and then after you get the dy dx answer, you just integrate it. You add an integrate. In this case, yeah, we arrive at the ln relationship. Of course, in exam you won't see ln here anymore. All right. So you have an equation here. X, y equal to a constant. Constant means it can be 0, it can be 1, 2, any round number. Okay. Now again, for this module, you can use online platform to help you to plot graph, and you just copy the shape into your answer, and then you draft it out. Just copy whatever you see on the online calculator. Now, how do you get this online calculator? You can even try on using your handphone now. So so what you do is you go to the Google, and then you Google you go to Google. All right, you go to Google, and then you type right, you go Google, and then you type you search for curve plotter. Right, curve plotter, click the first one. You will see either is Desmond something, or the second link you will see is a transient something. Both works, both works. I'll show you, curve plotter. You can either use the first one or second one. Actually, it's the same platform. So here on the left hand side is your input with your keypad here, or if you're using your mobile phone, the keypad is also the same orientation. And then this is the presentation of your graph paper. So how to key in the plot, how to ask the computer to plot for you, you just hover to the first insert here. If you use computer, you just move your mouse there and then click, and then expand your keypad. Expand your keypad. Now, equation just now is xy equal to constant value. So you just go and find the x, and then type the y, and then go and find the equal. We start with 0 first. Xy equal to 0 is a straight line. And then we start with, we try to look at a different number. So second constant number, you can even use your mouse keypad, means your keyboard. So you can type xy equal to 1. So this blue line referring to xy equal to 1. And then you can repeat the same, equal to 2, and so on. So what happened to the negative value? Xy equal to -1. -1 also is a constant value. So xy equal to -2. Right? So these are the shape that you can copy into your answer sheet when this comes to exam. Just be careful on the definition. So if the
this is
sorry
the stream,
sorry again.
this is the streamline.
Yes, this is the streamline for equation xy equal to constant value.
Okay.
So these are all the streamline. Of course, the differences is the constant value.
Okay.
So if the question asks you to plot only x more than positive, then you can only copy the right hand quadrant. You don't copy the full graph. If you give me the full graph, means you're wrong. You don't understand what is the boundary condition.
Okay.
All right. Yeah. So you can do the same for the previous example in question 7 just now. You can do the same. So you just need to explore a bit how to move, how to operate the function here. All right. So yeah. So for this module, you can use online platform to find the answer for you. I mean, for plotting graph. What you need to do is just extract the shape and then you copy the shape into your answer sheet. Then you take a photo as the answer. Right? So of course you need to label like for example, this blue line equal to x equal to 1 in your answer, the green line equal to x equal to 2 in your answer, for example. Right? So this is how it works for this module. So because everything in this module will be online. So and also when you go to work also, you already access to all these smart tools already. All right. So okay. So if you insert all the value, you will get similar shape. So of course, this example here is for the streamline for x more than 0. Right. So you have your C, the constant value equal to 1, -1, 4, 9, right? And then this axis also. You can try different value. Then you'll get the shape of this line. And then the direction of this flow, you can refer to the question 7 just now, just to know the direction of all this. Okay. We have clear for streamline question, which is question 12. Then we go for definition for your stick line and your path line. So what is stick line? Stick line is, this is textbook definition. Stick line, it consists of all particles in the flow that have previously passed through a common point. So for example, if you throw a basketball and then you use a camera to capture in a different time, means you open up the shutter and then you can capture all these gray color basketball image. So all these gray color basketball is your stick line. All right, so you just imagine that you have a camera and then you throw a basketball. The basketball will flow, right? Will flow in a certain pattern. And if you combine all the photo at a certain time together, you get a certain shape or movement of the basketball. In this case, you consist of the gray color basketball. Gray color basketball is the stick line. So that's why we mentioned stick line and path line only you can determine in the experiment. Of course, now with the software, you can also use, visualize it with the software. All right. Now, so this is also another example to understand the stick line. So you can see the 1, 2, 3, the third line here. You see there's some cloud flowing. So this is the actually video is also video actually is a repetition of a stationary photo. So you see there's a white cloud flowing across when the time change. So this actually is an application of the stick line. Then the path line. Path line is the red dot color. Path line is a red dot line that follow the gray color image. So textbook definition, path line is the line traced out by given particles at the flow from one point to another point. So path line is the red color, red dot color. Okay, so path line also can determine through experiment only.
Yeah, okay.
Okay, let's look at example. How do we plot in this example question 15? It asks you to plot or plot a streamline by a given equation. So this is just a repetition of question 12, and just to reinforce what we learned just now. So here it straight away give you the u and v component. All right. So you need to determine the equation of the streamline, and then you plot it out. So procedure is very simple. Recall the streamline equation, this one, or dy dx equal to v divided by u. So when you write this one out, you get 1 mark. All right. So yeah, this diagram is just to help you to understand this equation. So in exam, when you write this one out, it will give you 1 mark or some marks for to prove that you understand the definition of the streamline. Then after that, you substitute whatever that given in the question. So here you have u and v. You substitute your v value, u value there. Then after that, you do the integration procedure. You just move your y to one side, x to one side. Okay, your x one side, y one side. Then add in the integration sign. And of course, without the boundary condition of the integration, you will have a constant value just now. Right. So you have a constant value at both sides. If you integrate from here to here, you have constant value on one side, constant value on one side, because each integration gives you one constant value. Because you don't have a boundary condition here. All right, you don't have this one, so that's why you have a constant value 1 and 2. So we need to determine our constant value. So you just combine the equation. So x equal to y squared divided by 2 plus y plus constant value. C is a combination of C1 and C2. We write in this form because it's more easier for us to define the streamline. You can write in y2 equal to something also, but it's more easier you write something without with the n equal to 1 here as your subject. You got x, right? So this is just a strategy we use to solve a mathematic question. All right, and then you want to find the constant value. You use boundary condition. This is a step we call it boundary condition. Boundary condition, that's like you put in the coordinate, x equal to what, y equal to what. So more easier one is at the origin. You always start with origin. You start with the x0, y0. So x equal to 0, y0, what is the constant value? All right, so x0, y0, c equal to 0. So you don't have a constant value in this case. All right, so this is the equation you're looking for. All right, so there are some marks for this boundary condition. And then simplification, this one also have marks. So most of the student, they will forget about this one. They'll forget to find constant value. In this case, it's very straightforward because it don't have constant value. In later example, you will see that your constant value have something. In this one is a straightforward example. Okay, any question up to this answer? Okay, good. Right, and then yeah, plot the streamline. I already show you how to use the online platform. So this is on the screen here. We just type in x equal to y plus, of course, 0.2, 0.5 is half lah. So you can use 1/2 times y square also can. Right? So this component, you go and explore a little bit, you get familiar with this platform. After you plug in the equation, you will plot for you. This is the shape of your streamline. Then you copy lah. You copy the shape of the streamline.
Okay.
Right? So yep. And then okay, now we're going to go for direction already. So just now we do not teach you how to find direction. So now this is the time we teach you whether this flow is coming from the top or coming from the bottom. All right, now recall the dy dx equation. Dy over dx equal to v divided by u equation to find the direction. And we assume our v will equal to 1. Not assume, but is given. V equal to 1 in the question. Means v is always positive. Means this component is always positive. Means your v always going up. All right. And then your u, you look at your u. Your u also don't have negative sign. So it's going this way. You combine u and v, you plot, not plot, but you draw out your vector, resultant vector from the origin to the endpoint. You get going up. So this one, you plot on the positive quadrant here. Right, this graph represents a positive quadrant. So on the graph here, straight away, you know that it's going up like that. And you know that streamline actually is a continuous of point. So you have one direction already. Of course, bottom one should be follow the direction. This one by intuitive, because once you find this one, this direction already, you already know what is the direction from the bottom. Because all this line is a continuous line. Okay, this is how you find the direction. Right. Now again, he asks you what is the float speed at origin. What is float speed at origin here? So how to find your float speed? Again, call out the velocity vector if you want. Right. So in this case, y equal to 0, x equal to 0 again, because it asks you to find speed at origin. So you call back the two equations. Substitute y value. You get u equal to 1, v equal to 1. And then call out this equation to find the magnitude for your float speed. If you write this one out, you're given marks in exam. Why general equation is very important for your exam? Because sometimes you press the wrong calculator, you get the wrong answer. This one will be like your safety jacket to secure some point. Right? Knowing uv equal to 1, we don't have z component here. So you just do the mathematics, you get 1 point. Because
u1 and v1, it's we're taking from the equations from the vectors.
Correct. Because
It's 1 plus y. Yeah, because
because just now,
it's 1 plus y.
you, 1 plus y. Yeah, because 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 1 plus y just now, because u is 1, v is 1. You understand why we get 1? How we get 1 for each one of these? You understand why we can get 1? Why? Because it asks you at the origin. At the origin, what is the coordinate for origin?
0,
0,
0.
0. What is the u given equation? 1
1.
plus y. V equal to 1.
Okay.
So this is given. So you substitute y 0, you get 1. So 1, 1. So square 1 plus square 1, you get square root of 2. 2 square root, you get 1.441. Of course, the unit is not given in this statement. If you really want to go for dimensional analysis, then you write unit over second. Means there's a unit inside the graph there, or inside the velocity field. It means you just write a general term to represent that, okay, this is a unit per second, is a speed. So in the exam, also very important for unit lah. So if you forget to write the unit, then maybe if this was awarded 2 points, then if you forget about unit, then you won't get full mark for 2. Maybe you only score 1 mark for answer. Okay, so this is how we solve lah. Okay, so for the previous class, you already follow this example already, right?
Yeah, already.
Yeah, so I think we can stop at here.
I have another question, sir.
Hold on, I stopped the recording first.
Okay.
Recording first.